So here we have another example, slightly different form. The main difference, of course, is not where the x squared, or whether it's x squared or x to the fourth or cubed or whatever, but the fact, or whether it's in the top or in the bottom. But the main difference is going to be the difference in the square root, right? Because the square root, where the x is and whether it's plus or minus, is going to determine our substitution. So if we look at the triangle that is associated with this form of the square root, all right, we see that we have the square root of x squared minus something. So whenever you've got something there that's minus whatever, that thing here, that in which case our x here is going to be on the hypotenuse, right? Because you're starting from a squared plus b squared equals c squared. So if I'm solving for something, it's going to be c squared minus something, right? So my x is going to be here. Now what about the other two legs? Well, one of them is going to be 4, and one of them is going to be the square root. Now, which one is which? Actually, it doesn't really matter. The difference if you switch around the two legs is just going to be, instead of the function, you might have the cofunction. For example, in the one where we had sine of theta, if we had switched the two legs and we had constructed the thing, we would have used x equals cosine theta. Well, it would just about change the integral around a little bit. There are a few minuses here and there. It would have ended up in the same way. Very similar situation here. The way I set this up, in order to figure out what is my relationship between x and theta, of course, I don't want to pick the square root. I want to pick the most simple thing. The simplest thing, of course, is going to be with x and 4. But now I've got the x on the hypotenuse, right? So what's the relationship between these two? I can think about cosine theta being adjacent over hypotenuse, and I always think about it that way because I always think sine, SOHCAHTOA, sine, cosine, tangent. I don't remember the other ones. But now I can see that if I solve for x, I'm going to get 4 over cosine theta. So this is 4 secant theta. So this is going to be what my substitution is. If I had chosen the 4 here, it would have been sine, it would have been cosecant. My integrals would have been with cosecants and cotangents. That's not going to be a big difference. All right. Now, what about dx? Dx is then going to be 4 secant theta tangent theta d theta. Right? So fine, and then what about the square root? Now you can see again, I want to not have the x being in there too much. So if I look at solving for the square root, tangent of theta, I'm just going to maybe write it here. Tangent of theta is the square root over 4, right? Because it's opposite over adjacent. So that gives me, as I solve for the square root, to substitute that guy in there, will be 4 tangent of theta. All right. Now I'm going to substitute everything in. I want to make sure, of course, that all the x's go away and there's only thetas left. So like with any substitution, you're not mixing the stuff up. Everything goes from one variable to the other. So for the dx, I'm going to put the 4 secant theta tangent theta d theta on the top. And then this bottom, x was 4 secant theta, so I have this squared. And then this square root was 4 tangent theta. Okay, so let's see. These tangent thetas cancel out. These 4s cancel out. And oh, look at that. That's really nice. So this looked really terrible when it was looking like this, right? But now look what happens. So I've got this secant theta cancels with one of these secant thetas, right? So we have to be careful. I want to be careful about this. the secant theta cancels with one of these, or you can even have done those with those, but in any case, there's still an extra 2 4s down here. So I end up with 1/16 and then d theta and 1 secant theta in the bottom. But what is that, right? Secant theta, right? It's actually, 1 over secant theta. This is just cosine. So after all of that, everything canceled out pretty nicely there. And then I end up with this integral, which is super easy to do, right? So I just get sine of theta here. And I'll throw my plus c so I don't forget. And then what is sine of theta? Well, I have to go and figure out what the sine of theta is from this thing, right? Because I've figured out some secants, tangents, cosines, but I can just read it off the triangle, right? Because sine of theta is opposite over hypotenuse. So sine theta, going back to my triangle, is opposite, which is this thing, over hypotenuse, which is that. And then finally, I get my answer, which is then this square root of x squared minus 16 over 16x plus c. So if you wanted to check that, then of course you could take the derivative always of this and see that eventually you would get that, right? You have a little bit of work going on there with the quotient rule and everything, but it works out.